So my name is Murray Oldfield. I'm a technology architect here at InterSystems. I work with Mark Bolinsky, who's the chief technology architect here too. So our job is we work primarily in the triangle of you guys, the customers, to make you successful, vendors, and within InterSystems. And we try and communicate between so that we get the best outcomes as far as infrastructure. And I'm not talking about just like hardware and those type of things, but how to get the best out of the operating system or your storage or your storage vendor, or in fact out of IRIS itself. Now this talk came about because one of my tasks this year is to work on some of our vertical products, Track Care and Health Share, and just get better at the way we deploy things. And so, it seemed to be a good fit for a session here at Global Summit. I like this picture here, to automate the boring stuff. If I have to do something twice, I'm starting to look at ways to automate it. And that's really the whole idea here too. As we get into deploying IRIS, which is sort of the focus of this, although the methodologies I'm going to talk about could be just as useful for deploying infrastructure, like your VMs or your AWS or Azure or whatever you're doing. Now we all know what needs automation. We need to set up the systems, make sure that they're in a fit state to start. And then we're going to install IRIS and configure it to the best practices and get your application up and going. And then, of course, there's the day two stuff, which is beyond deployment, but just about as important because you want to keep your systems running in a good way, make sure they don't drift off from where they should be. And also, it's quite possible that you going to be updating software various times. So you want to automate all of this stuff. And back in the day, I'm looking around the room. There's a few wrinkles. I'm old enough myself. It used to be relatively simple to set up systems. We'd be setting up a few, but now the volume is just getting bigger and bigger. This is, to be fair, an edge case, but this is a system we sized out recently for a health information exchange for a statewide health system in the US here. It's got 122 VMs. And that's across production, your mirrors, your non-prod stuff like test and dev and staging and your DR systems as well. All of those systems, 132 instances of IRIS itself, and 1,100 namespaces. The edge gateways, some of them had, they've got 10 each and they're mirrored, so just like mushrooms. And within that too, that little screenshot in the background there, that's out of our sizing system. So this is how we configure. We have a system where we put in all our variables and we configure it out, and we create what we call a build spreadsheet. So you can imagine the build spreadsheet for 122 VMs, and within each of that, it describes things like you've got your CPU and your memory, but also how much memory is for global buffers and routine buffers and GM heap and all of that. So the aim of this is to not be working off spreadsheets, but to get the information out of that into some sort of automated fashion as well. So the end goal of my work, which isn't finished yet, is to have this deployment automated straight out of our build spreadsheet system. So where most people start is the situation where you're doing, basically there's a checklist of stuff you have to do to install your application or install your test servers or dev or whatever you're doing. And it's it's a combination of cut and paste, and it's I might be putting stuff in the OS terminal, IRIS terminal, maybe configure some stuff through the SMP because it's too hard, and you get this list. But what I'm trying to illustrate here with Claire and Frank and Lee down the side there, people are working off different lists. Within InterSystems, we have worldwide force that does track care implementations, for example. We want all the regions to be working off the same source. We want all the people within the regions to be working off the same source. And we get this situation all the time where, Anne's up to date. She's fantastic. She's got the latest one. But poor old Frank, he's either picked up the wrong one or he's gone to sleep and everyone knows when Frank installs, something is going to go wrong. So what we want to do is bring this all together and control it. So why do we do this? I think a lot of this is really quite obvious, but I think one of the big wins out of all of this is, as I talked about the scalability, the ability to deploy many systems and many systems in parallel, in fact, I think one of the real key wins is configuration management. Once we start to use this infrastructure as code methodology, where you're deploying not just with scripts, but sort of a step beyond, what we're doing now is, this is something that is self-documenting, because as you build these out, and as you'll see, is a very formal way of doing it, which makes everything documented. It means you can put in a source code control system like Git or whatever. So now if Frank needs to install track care, he can just go and pull the latest. And then out of the build spreadsheet, he'll have some variables that plug into that, and he should be good to go. That's the theory. We'll see how far we go. So this picture here, I like this because the picture on the top there is what everybody tells us. Any vendor of any software for automation is going to tell you what happens is, you write your stuff at the beginning, and then the sun comes out and you can move on to more valuable tasks, whatever they may be. I think the reality is somewhere down in the bottom picture where you do automate something and you have some scripts, but then if you're the person who wrote the scripts, guess who's going to maintain the scripts? You. And so now you've got a job for life. So what we want to do is just lower the curve here on this ongoing development, so it is something that ticks over, something that's done as required, something that you can hand off to other people, even more importantly, I think. So there's all sorts of ways of doing it. Shell scripts, when I started back in the day, that was how you did everything. And when I started working with Mark in the 2010s or whatever, we did a lot of benchmarks together. And so we would turn up at HP or IBM or somewhere, and we'd have a window to work in because we'd be on site. We needed a fast way to deploy stuff. And that's when I started working with Ansible around about 2014 or so. Ansible's what we're going to really be talking about here today, and the methodology with that. Ansible is open source. Around about 2015 or 16, it was bought by Red Hat, which was subsequently bought by IBM. But there is still an open source free version of Ansible, and that's what I'm talking about. I'm not talking about the paid version. So let's see how I'm going to achieve my goal of getting these automated deployments done with Ansible, but for IRIS. So I'm going to concentrate on the IRIS block. I'm not going to talk about infrastructure in this, but like I said, the same methodology applies. I'm going to show you an example, and then I'm going to set the background with Ansible, because you need to sort of grok that, how that works, and then from then everything sort of just flows on from there. So we'll talk about some specific Ansible things and some specific things I've done with the IRIS, with the modules specifically that I've written for IRIS, and that can be the start of something more. And the wait there's more is, what time do we finish? 2:15, did you say? Yes. So the wait there's more, we'll see how far we get through that before it's time to wrap up. I know that you're... So Ansible community is what I'm talking about. The Ansible has, like I said, a paid model. It's like Red Hat. You pay a subscription and you get support, you get validated software and so on. It's called AAP, Ansible Automation Platform. And it has lots of nice features. You know, some of you may even be using it already. It's up to you whether you sort of decide that's better for you. But certainly for me, I've chosen Ansible, and I chose it back in the day for a couple of key reasons. One is it was free, it was very easy to pick up and easy to understand and easy to use. And also, you don't need any agents or anything on your target systems. So you have all that you need, say, on your laptop or on a location, an instance somewhere, and you don't need anything. So when we would turn up at a benchmark site, we didn't have to pre-install stuff on the hosts. All we needed was the IP addresses and the logons. So this is how it works. This is a very simple picture, as you can see. You've got a remote instance, which in Ansible terms is called the control node. On that is installed Ansible. Ansible is written in Python. So essentially, when you install Ansible, you're installing a version of Python. And then you might install some extra community modules for, if you're working with AWS, for example. Just like I'm going to show you with IRIS, if you're working with AWS or Azure or Cisco switches or whatever, you can add on to this. So it's a very extensible platform. So if something doesn't come with it, you can add on to it. You connect through, everything's done through SSH. So as long as you can set up a trusted connection to your hosts, you're golden. So you just need SSH on each of your machines and however many that you're going to be working on. Now, all the sessions this week have been talking about AI. All the keynotes have been about AI. So I thought I would throw some AI into this. So I gave this picture here to ChatGPT 4.0, and I said, can you do me a nice picture for a presentation? That's what I got. It looks incredibly complex, and in fact, it looks like it's come from Mars or something. So it is simple, like it truly is. It's actually very simple to understand. Connect, do stuff. That's about it. All right, so Ansible uses YAML files to describe the things that have to be done. They're fairly straightforward. And this is where I talked about the self-documenting. So you can see it's just a text file, which you can save to GitHub or your source code control system. And it's based on these stanzas here. So I'm not going to, this isn't a lesson on Ansible. I'm going to just hopefully show you enough to show you how I put these building blocks together. So that Ansible built-in file that's there in the square box, that's the name of an Ansible module. It's called file. And what does file do? It has it's a very Unix philosophy. Do one thing well. Just do one thing. Don't be complex. So the file one, it's got a path. So I've got in those curly brackets there, that's a variable. And this is a real key to Ansible as well. This is how we can reuse scripts over and over again. We're not rebuilding stuff. We use the same script, but we just put different variables in, depending whether we're installing an edge gateway or a track care or your application. You could use the same little bit of script. You just have different variables for the path. The state directory, that just says, I want to create a directory here, and the mode, the permissions. I think most of you would recognize that. The copy one is very sort of relatively easy to read. Like I've got a source and a destination, the owner, group, mode. The force at the bottom just says, if this file exists already, don't try and overwrite it. Just move on. So you can see how you've got a lot of control just in this built-in. And I'll introduce like the when clause at the bottom. It'll only do this little block of code when it's a Red Hat version 9, for example. So you've got a lot of control within. But you're not reading code here. This is fairly easy to read. You can understand what's going on. And you can see this is just the state directory part. Depending what you put there, if you put state absent and if that directory path exists, it will remove it. And this is another key concept of Ansible, is it's declarative. You're saying, I want my system to look like this. You describe the end state. I describe my end state as having a directory on that file path, and I want those permissions. If it doesn't look like that, it will make a change and make it look like that. If it does look like that already, it will skip that step and move on. And that's a term that you'll hear called idempotent. To be honest, I don't know what that means. It just means that you can run the same thing over and over again, and you're describing the end state, you'll get the end state at the end. You could run the script 10 times, you'll always get the same result. You could change something, run it again, and it'll fix it for you. Right, I'm going to do a demo, and I'm not insane, so this is a recorded demo. This is installing IRIS. So what's happening here is, see the lines with the asterisks on? They're that first little name thing. So that's the description of what's happening here. Now the output is coming out on the screen because I ran it from the command line. You could just as easily run this not from the command line, and the output can go to a log file, and you can check it afterwards. So what you can see happening here is I'm installing 5 servers in parallel. So it's running things like that file thing you saw, so creating directories. You'll see it's uncompressing an install file on the server now. It's setting the syscontrol, so it's setting the IRIS, the kernel parameters, and it's just echoing out the stuff. Now things are coming out in different colors because different things happened. If they're green, it means either everything was already set the way I've just told it to be set, or else a lot of my code's full of debug stuff, messages to tell me what's going on, especially in this demo code, which I'll give you access to after the session. Something that's, you saw some yellow stuff. The yellow stuff means a change happened. So we're installing Apache on Red Hat 9, just sort of shot past. So because Apache wasn't already on this machine, that's why it came out orange. Now we're creating groups, the users we want. That red stuff means something failed, on purpose or not. And now we're getting to the point now where we're actually running the IRIS installer. So the sort of takeaway here is that think about it like there's a lot of discrete little tasks. Your checklist is happening one after another. It's happening in parallel on multiple machines. It's sort of like just a big batch job. Just think about it like that. It's coming to the end. So I'm copying the IRIS key file up, and I'm stopping it, and I'm going to start IRIS, and we're all finished. So this, I've put a debug message out at the bottom here because I'm installing on AWS as it happens. So I just wanted to be able to click on those paths to get the SMP up, because AWS always has these weird names. And the important bit is this bit at the bottom, the recap. So you can see 45 things were green. Okay, that's good. 17 things changed on the way through. That was like creating the users and the directories and whatever. And it's per machine. So it's telling you on each system what happened. They could be, because we ran on clean machines, it happened on every one of them. Now, some things were skipped and some were ignored. We won't get into that at the moment. But this output, now think about this. This is our install, and we can look at this and say, well, that looks good. But this script could be run again. It won't install IRIS again. What it will do is give you a checklist of what might have changed. Like, you can either run it again and make the changes happen, or you can actually run Ansible in a mode called check mode, which will just go through and see what would happen, and then you'll get the list at the bottom. So this is a good way to validate a system after it's been installed as well, and see what would have changed. The way Ansible's set up is the best way is to set it up in a directory structure, because Ansible is aware of this directory, and you order things into sort of major groups, roles. So we'll talk about roles in a second, and within a role you have discrete tasks, and and we'll get into that. And this idea of playbooks is where you group together roles to create something to happen. So that install IRIS you saw there was me running a playbook called install IRIS DB servers, which was made up of several roles which had tasks inside them. So this is sort of zooming in on a role called install IRIS. So that was one of the, not that whole step, that was just one of those blocks in that step. So in that I've got multiple tasks. Usually you run off a main script, and then you can sort of read the text there. It's pretty, my variable names too are just about whole sentences or paragraphs just about sometimes. So you can see there that there's a bunch of stuff. There's an IRIS install silent, there's transfer the files to the machine, configure OS. So these separate tasks are run in a certain order. So the whole idea is you template out your IRIS install, and then you can use it over and over again, and we'll get onto the variables. The koala bear is there because I said a great methodology to follow here is the dry methodology. Does anyone know what dry stands for in this context? DRY? Any guesses? Don't repeat yourself, did somebody say? You get a koala bear. So this idea of playbooks, like I said, what we're doing is we're getting the roles and we're putting them together in a playbook. And we can mix and match. So it's like the Lego set that Ari was showing in one of his sessions. We're just starting to put things together like a machine. We're putting a machine together here. And within those roles, we have tasks, and like I said, the main task will just include what you need. And you could have like that when clause to say, do this, don't do that under these circumstances. Here's a task I've zoomed in. This is from the install Apache task. Above the red dotted line is installing it on Red Hat 9, and below is installing on Ubuntu. Can anybody spot any differences between above and below the line? Anything? Any guesses? There's koala bear. Yeah? Exactly. So koala bear for you too, sir. So for example, using that when clause, I'm saying when I'm running on Red Hat, use yum and install HTTPD. I could also use DNF. And below the line, the Ubuntu, I'm saying use apt because it uses a different install package manager. So this is the one install Apache script. Now there's stuff above and below this for configuring the WebSys gateway and so on. But you can see how just one script can be multi-use. You don't have to have a separate one for Ubuntu because you're just making things more complicated. You want to simplify stuff. There's this idea of inventories, and it's very powerful because it's like a host file, but it's a host file that can be nested. So in this example, in the square red box, I've got my health share servers, which is actually a grouping of my UCR and my edge servers. So if I want to install all of health share, I could address my health share servers, or I could just address the UCR servers, or in fact, I could just address DB servers or even just one server if I wanted to perform some action. So this is a way of, when you run your playbook, segmenting off what it is that you're going to be running on. And the real power of this is because you can group your variables based on those host groups. So for example, the group variables there for DB servers, which was the top one up here, this little group here of a couple of DB servers, say a mirror, is that the OS settings for a DB server I want my OS swappiness to 5 and whatever, and I want my IRIS install variables to be, the instance name, which could be a variable in its own self. Like I said, there's this hierarchy of variables. But the important thing is that when I'm running, my install IRIS script, it's going to, because I'm running them on the DB servers, it's going to read in the DB server variables. And you can see that the variable file also has variables in it. So you can sort of nest them as well. So you can have an order of precedence. And here's just another example, but this time it's different operating system packages depending on what operating system. So I wanted to tell you about Ansible secrets. So Ansible Vault comes in free with Ansible, so we're moving on to some more interesting stuff now. So it protects data at rest. It's like IRIS database encryption. What you do is that you can encrypt a file, you can decrypt it, but once it's encrypted at rest. So now my IRIS key file is just a jumble of letters and numbers. You can encrypt, a file like this. You can encrypt your variables, like a username and password or something if you have defaults for those. And when you run your scripts, you can either have a flag there to prompt someone to put a password in to have access to the vault, and therefore, now your IRIS key, when it's copied up to the server, is decrypted. What I do for these type of things is I use a hidden file called vault password or .vault password, and I have that in my git ignore file, so it's never copied up to my GitHub. And also, you could easily have that password also, like in whatever your key management system is. But the key messages here is that you can encrypt, your secrets. They'll just be decrypted as they're used. So modules and plugins. Now we talked about a couple of modules already, like the file and the copy. And you can see here, this is just a little bit of the list of the community the collection of different modules that are available. So the ones in the top square box are the ones that, like the Ansible ones. All the rest are different from like vendors like AWS or Cisco or whoever. And then there's the community supported ones. So there's a very rich collection out there. And remember, like the file one, their job is to do one job well. So what I've done, as I started to go on this project to automate our systems, there's some opportunities to create some modules for IRIS. Now I've started down the path, and by the time I finish my project, there'll be some more. But I'm going to publish them on GitHub so that it becomes, and also there's an accompanying community post. The idea is that if you're going to be using Ansible and IRIS together, we can create a community Ansible, and then it's not supported by InterSystems, but it's something that people who use InterSystems IRIS can use, either download it or fork it, or just use it as an inspiration for creating the things that you want to do. So to get going, I thought, well, what's something useful? So most people, who's run the IRIS QList command? There's only 2 people, three, so I reckon that's worth 3 koala bears. So what IRIS QList does, it's just a command line, and what it spits out, if you don't put the instance name, it will just spit out the string here separated by the caret of key information about IRIS. So I thought, well, let's try that. So I did an execute. I created a module called IRIS QList, which basically runs that command. But the important thing is that what it does is it doesn't print out a list of, with the caret. That wouldn't be much good to anybody. I could have just done that. What it does is it outputs a dictionary with key value pairs with those values in it. And what I can do with them now is they can be variables. So remember, we're using variables all the time. So now I've got my instance name or the IRIS install directory of that instance, for example, which I can use later on in my script. So you can make your scripts a little bit, you can make these things about your IRIS instance discoverable. And it's just very easy to call, and within Ansible, it's very easy to turn those things into variables. So the next thing, here's some Python code. That's all I'll say about that. The important thing is there is some Python code which takes that output and cuts it up and does some stuff to it. But the idea is that any complexity is hidden inside this module. Outside, you could have this down to like 2 lines, and we're getting this information. We're not, back in the day when I first started using Ansible, I'd be using awk and set and cut and things like and you don't want that. It makes things too complicated. It makes things harder for other people to maintain. And one mistake and it all goes to hell in a handbasket. So the next one I came across, if you just from the command shell in Ansible do an IRIS stop command, and IRIS is already stopped, you'll get an error message back because the return code is not 0, it's 1. And remember, Ansible's running like a batch file, one after another. If it gets an error, by default, it will stop dead there. So whatever you're doing on that host is going to stop working and you're going to have to fix it. So I didn't like that to start with. I wanted to be able to recognize that had happened and be able to, if it was stopped, just remember we're declaring, I want this to be stopped. If it's stopped, good. That's actually what I wanted, and I'll keep going. So it's this I shouldn't keep saying that word. So in this example, you can see it's just like the QList one. I've got the IRIS start stop module, that's the name of it. Instance name, action, start or stop, if you can imagine. At the bottom one, you can see I've also got a couple of other parameters like quietly and restart. So quite a common command is IRIS stop instance, quietly restart. You often do that to restart IRIS after you made a configuration change or something. So that's now encapsulated just in that little one there. So I'm going to veer off to the side here of one of my pet peeves. Who uses Linux huge pages on their Linux systems? Too many for koala bears, I'm sorry. So who runs Linux and doesn't use huge pages? A few people. So what huge pages do is in Linux and AIX and Windows has large pages. What happens is you have a page table made up of lots of little 4K blocks of memory. And remember, IRIS is an in-memory database, so we're loading all our global buffers and routine buffers and GM heap up into memory. And we want that to be really fast and really super performant and accessible. If you use huge pages, you get these bigger memory pages, which means that there's a lot less control at the kernel level, and so that the system is just more performant. It also has a couple of other good side effects. Is if we put aside huge pages and IRIS detects it and starts in huge pages, it means that we're separated from other things, processes that are going on the operating system. So there's a couple of really good benefits for your database servers, for example. You don't use huge pages for a web server. You use them for your database server with all your shared memory. So a common rule of thumb for like a big database server for an application like TrackCare or HealthShare, and probably your applications as well, is we use about 75 to 80% of the memory is going to be for global buffers and routine buffers and all the shared memory. In-memory database, we want as much in memory as possible. TrackCare only has about 200 processes. It's a web-based application. So it doesn't need a lot of free memory for just the processes. That would be in the other pile there. We do direct I/O, so we don't need we don't need file memory. What was it? File cache, yeah, good. Either. So we can sort of allocate huge blocks to just shared memory. And remember from our build spreadsheet, we worked out, well, we're going to have this number of global buffers and so on. This is optimal for this type of IRIS instance. And then, well, now we have to, at the kernel, allocate huge pages. And you allocate them in 2 meg pieces. There is a calculation at the bottom there, which is pretty complex and not always correct. So when I'm doing that build spreadsheet, one of the columns there is number of huge pages. So this is for the person installing this instance to go in and set the kernel up for this many huge pages. However, if you don't allocate enough huge pages, and even just by one, then IRIS by default, when it starts up, will say, well, there's not enough huge pages for me. I'm going to start up in what's left. And we're starting up now in 20% of the system of memory, and IRIS won't fit in there either. So it'll just keep making your global buffers smaller and smaller and smaller until it fits. And unless you're looking for that, that'll happen basically silently. It means your system will come up, but now you're running in a very constrained memory space. And this is quite a common problem. You know, people report poor performance, and then we look and we find out that they're not using huge pages at all. That's just wasted memory now. And the other side of the coin is that you allocate too much, you only have a smaller amount of shared memory, and now you've wasted a whole bunch of memory. So coming back to the sizing, what we tell, for example, the TrackCare installers is set up everything, start IRIS, go and have a look for this line here on the output, or look in the messages.log. It'll tell you how much shared memory it's using. So in this case, it's whatever it is. And then calculate your kernel parameter for huge pages, set that, restart IRIS, and now you're good to go. So one of the things that I noticed with these modules is for the start and the stop, that information actually comes out, that piece here that I showed you with the big arrow comes out. So what I can do in my start stop is I can grab that as well. So now the procedure is when I start IRIS, that start IRIS command, one of the things, just like the queue list that it returns, is a dictionary of the parameters, for example, how much shared memory, how much global buffers, routine buffers, and also calculate how many huge pages based on what it's actually using. So now there's an automated way to say, when I run start IRIS, that red there is because I had 2 servers. I got an Ubuntu server and a Red Hat server. The Ubuntu didn't have IRIS on it. So when I do the IRIS start stop, it just fails and stops. But from then on, I'm outputting these values. I've stopped IRIS, and now I've set the kernel parameters for huge pages based on what was actually used, and it's done. The stuff in blue there that's skipped is I also do a check to make sure that the huge pages I asked for are actually allocated, because if you ask for this much huge pages but there's been memory fragmentation, you won't get it. You'll get some less amount. And if that doesn't work, it does a reboot of the OS to come up and get the contiguous pages. Now, whether you want to do that or not in your production systems is a whole other question, but that's what I did. One of the other great things that I found, so moving on from that, one of the other great things I've found is CPF merge. Back in the day, what we'd do is, we would use, this is actually Ansible, set a whole bunch of variables and so on, and then run this into a shell command, pipe it into a shell command. But with CPF merge, Who's used CPF merge? Anybody? Not many, only probably a third of people. What CPF merge does is it lets you, once again, it's declarative. You're saying, this is what I want my CPF file to look like. So in this example, you can see freeze on error is set to 1, for example. It's not by default. I want my GM heap and things to be these. And so when IRIS starts up, if you have an environment variable set that says IRIS CPF merge file and it points to a valid CPF merge file, it will read that in as IRIS starts up and apply those configuration settings to your CPF file. So this is a great way. Remember, we're automating stuff straight out of the build spreadsheet, straight into an IRIS CPF merge file that can be, on the first startup, can be automatically put in, or at some later time if you want. So here I'm doing a restart. You can see I'm doing a IRIS start stop instance IRIS, and then I'm doing a start quietly. And another great use is that if you do find yourself sort of mixing and matching between modules and maybe piping stuff into a terminal IRIS terminal prompt, one of the key things you have to do is set operating system authentication on. And you can't do that from the command line because you're not authorized to yet. But with the CPF merge file, what you can do is just use the actions feature of CPF merge, which is access to all the system security stuff. So actions aren't just like changing a setting like freeze on error to 1. It's going off and doing stuff. So there's a huge number of these things that you can do. Actually, it sort of flew past, and I didn't mention it, but I was creating databases and namespaces in that first example as well. Like a tip here is that the first time I ran this, I set that the square stuff here to operating system authentication on, and then I locked myself out of the system because it's not cumulative. You're declaring, I want the system to look like this with all of, like, I want LDAP, I want system authentication, and all these other things. So you have to put everything there that you want. But this is great because once you've done that, then you can run in terminal commands, the old-fashioned way if you want to, as just part of your normal procedures. Okay, we're on to the wait, there's more. One of the great things I like is this idea, when Ansible first starts, when it first runs, it goes out to each host and pulls back heaps of information, hundreds of variables from each host. And you can take advantage of that. So just like I was setting variables like paths and things myself, so I've just sort of collected a few here, like whether you care or not whether you're running on a T3 large or what your processor or how many cores, but all of this information is available to you, what GP3 disks or what Azure disks you're running and so on. So these are variables that are available to you right from the start in your script to use. And you can output them to a JSON file or something like that if you wanted to have a record of what a system looked like, for example, as well. One of the other great things is J2. It's not our deployment partner, it's Ginger2 templates. So these are templates you make with, see the curly brackets again here, so, whoops, here. And so what that means is that I can have template files with variables in them. For this is for setting systemd, so IRIS will always restart on a system reboot. So you have to set up the service. Well, I need the IRIS instance name. Well, I'll get the IRIS instance name, somehow, and put it in there. So you can see the command there is use the template. The source file is this J2, which will have the variables stuck in, and then the destination is the service file for systemd. So that would be part of your deployment as well, to set systemd so that IRIS reboots every time you restart. There's many other things. I like the check one. I use tags a lot for, you'll see that in the demos that I'm going to publish. And so there's going to be a community post about like the IRIS start-stop script, for example. If you'd been outside my hotel room about 2 hours ago, you would have heard me shouting at GitHub. I couldn't get my GitHub tokens to work. So what I'll be doing is publishing the community posts. So just go and search for, using Ansible modules to deploy IRIS applications, when you get back next week, and it'll have links to the GitHub page and so on as well. And with that, please fill in the survey and happy travels. If you've qualified for a koala bear, please come up. No questions? Everything explained? Oh. Hi, no.
So do you have examples or documentation of how to do the actions like configure ECP between primary servers and application servers, or like setting OS?
Yep. So examples like that CPF merge, the actions for setting up ECP and so on. I don't, personally, it's in the documentation now. It's been in since about 22.1, I think, CPF merge. And also, if you haven't gone to the developer community website, I really recommend you do, because that type of question has probably been asked before, and somebody will have examples there. And if they don't, ask the question. Somebody will answer you. I forget what the number is now. There's thousands of people on community.
It's been really good.
Yeah, it's super.
So I want to point out one thing. I mean, Murray did mention earlier that this isn't officially supported by InterSystems, but it is community supported. So there's support there. Just WRC themselves, if you call up So I just want to make that clear that we're not just here you are, good luck kind of thing. We're going to be eating our own dog food on this, so it will be very active.
But as far as the modules go, like most of all, there's value in there being official releases of that.
We're going to get there.
Yeah, yes. I think we need more QD than Murray wrote some Python code. Because I'm sure if you examined it, you'd be shaking your head. You'd be going, what the hell is he doing here? So we'll get there, I think.
Yes, so the hard part was getting there and creating the first module. Expanding on it's going to be the easy part. And we're going to be adding specific tasks like, okay, my instance is installed, it's running. I just want to add now another database, or I want to add another global mapping, or I want to do something. So it will be a large library that keeps getting built up, similar to what CPF merge does in terms of actions. And that might even be a great template for us, is to take those actions and have them become actionable modules as well for things that can be done, especially things that can be done on IRIS on the fly that don't require a restart. Things that may require a restart, we'll probably just throw it in the CPF merge and just enforce it to restart. But things that can be done on the fly, I would imagine they'll become modules.
Yeah, so the most obvious example actually is that this one here, the CPF merge. I sort of glossed over it, but it's actually running a shell command to run the CPF merge because the system's up and running already. So it's like an obvious next one to run CPF merge, but not as a command, but just one of those modules.
Yeah. And not restart.
Yeah.
I wondered if you worked any with IKO or Kubernetes within.
I haven't personally.
So, yeah.
How that would play.
Yeah, so the goal will be eventually to have modules to do that, to deploy, because there are modules today for Docker, for Kubernetes. There's a large library out there today. Absolutely, integrate with Helm. You can run your Helm chart through this. Sorry.
You can mix and match too. You don't have to be all Ansible. In fact, there's sort of several pipelines. One is like Jenkins that calls Ansible. It's quite a common design pattern. Or you could be having Ansible calling, as you can see, IRIS routines or IPM. Yeah, it's up to you. Like Mark said, this is the dog food I'm eating at the moment. Some people say it's the champagne I'm drinking at the moment. Well, for me, it's whiskey, but you know what I mean. Cool. Yeah.
You said you got to define 1150 namespaces across that config. So you manually generating that in some way and using that CPF merge, or how do you handle it?
So that's where the beauty of the nesting of Ansible comes into play, because you can define it once and then say, well, I need 20 of these. And so that's where it starts exponentially doing all that work for you rather than having to define 1,100 of these things.
Because I'm not intimately familiar with how you define the namespace names within L-Chef. For example, in Edge, if you want 20 inbound feeds coming into 20 different namespaces.
Well, that's different. So that's getting into more of a Jenkins pipeline or even a CCR pipeline where you're adding interface code. This is more just getting the namespaces created, maybe doing an activation on it, and saying, okay, it's there, it's running, I'm on Edge, I'm talking to the registry, but there's no interfaces yet defined. That's implementation work.
Here's sort of like a trivial example of creating a database in a namespace. So you can see how that could be done with that template and variables. And an Edge, a lot of those namespaces are in Edge gateways. So you only have to know how to do one Edge gateway and you've done them all.
And especially in that case with that large configuration, this really brings in configuration hardening or configuration compliance. So over time, there may be drifts. Someone's in there clicking around and changing things. Inadvertently, maybe even. This can bring it back to home kind of thing. So that way you're not, all of a sudden, one Edge gateway's out here rogue and it's running weird and you have poor performance on this one only because something happened and it's not in compliance with everything else. So then this can reinforce it, like Mary was saying. If it's not that, it will set it back to that and move forward.
Cool. All right. I think it's drinks time, don't you?